Hey, what's up guys, Yankee here, and in this video we will be building a super fast RAG application using Semantic Cache. So if you have not watched my previous video about building a RAG application, first you need to go there and watch that video because we will be using the same code base, optimizing it using Semantic Cache and making the results super fast. Let's take a detour of our application and let's see where we can improve our previous application. As you can see in the figure, the most resource intensive steps in our application is cross-encoder re-ranking, and then there is the call to the large language model, which cost us both GPU cycles, CPU cycles, and if you are running it remotely, then cost as well. So we want to make sure that not all of the queries go through these steps. And how do we determine that? Let's say you are running a e-commerce store and there is a query about the new discounts that the user are questioning time and again. So if you are processing the same query again and again and again, then our previous application used to go through all of these steps again and again and again. But if we put a semantic cache in between, then what happens is that whenever a user asks a question, then we can check if the user's question is semantically similar to what we have stored in our database. And if the question is, let's say 80%, 90%, 70% similar, then we can immediately return the results back to the user so that our application does not have to go through these steps, saving us precious CPU cycles, GPU cycles. To get started, if you have not done my previous tutorial, make sure you do it. All the code resides in this repository. And for this tutorial as well, you are going to need this repository. So go to my GitHub page and you need to copy this and clone this on your machine to get started. So once you clone this repository, what you are going to do is run make setup on your machine, and it's going to install all of the dependencies, create virtual environment for you, and then it just suggests you to activate the virtual environment, and then you'll have something like venv on your machine. Once you're done that, we are ready to go. Let's also run make run to see how our application looks like. So it's going to be running in localhost 8501. Let's click on that. And this is what our application looks like. I will be starting this tutorial from the very start. So if you have any reminders from the previous tutorial like this database, then make sure you delete it before you continue. I just want to start with a clean slate for this one. And now to take this for a spin, we can again upload our PDF file. For this, I'm again going to use the AWS certified AI practitioner exam guide. I'm going to drag it, put it here, process it, and then I'm going to write what is the target candidate description arcs, and it's going to return me a answer that is going to be based on the document that I just uploaded. And it's also going to return some of the retrieved documents and where it fetched the answers from. Let's move back to our code editor. Let's stop this server for the time being. For semantic caching, we are going to need two new libraries. One is LangChain Olama with the version 0.2.2, and then we are going to need Redis, LangChain Redis in particular, which is going to be version 0.1.2. So let's install these dependencies. Make sure you are installing the exact dependencies so that you do not run into any issues when you are running this on your own machine. Once we have those dependencies installed, I'm going to go to my code editor, and then there are going to be a couple of new imports that I would like to add on my application. This includes string IO, CSV, because we are going to add CSV documents later on. And then we are going to use Olama embeddings for our Redis vector store and all of these Redis vector store instance and Redis configuration instance to configure our Redis vector store. I'll save this. And for the semantic caching, you are going to be needing a Redis instance that is going to be running external to our application. In particular, inside of a Docker container, we are not using ChromaDB, which we are already utilizing in our code base, because in a Streamlit application, the ChromaDB in-memory database is persistent within a session, and it's very difficult to work with because the in-memory database keeps getting erased. So for the best experience, we are going to be using Redis. So make sure you have Docker running on your machine, or let's say you have Redis server running as a server with a binary. It does not matter, but just make sure you have Redis running. If you have Docker running on your machine, you can put this command on your command line and run Docker. So it's going to be Docker run. We are going to be running it in a detached mode, and the port it's going to expose on our local machine is 6379, and the port it's going to attached to inside of the Docker container is also 6379, and we are using the official Redis stack image, and our container is running. With that in place, let's configure our Redis store. I'm going to minimize the system prompt, and at the very top, I'm going to add a function that's called getRedisStore, and it's going to return a Redis vector store instance. And for embedding, we are using Ollama embedding. Both of these comes from LangChain. So this is LangChain Ollama embeddings, and the vector Redis store comes from LangChain Redis. And for embedding, we are using Nomic Embed Text, the latest version, because it has a large context window and it supports a variable dimensions up to 700 something, which is pretty great for our use case. So this is the definition of the embedding function. And once we come down, we are returning a vector store or an instance of a vector store. We are passing the embedding function that it should be using to embed all of the queries going in and coming out. And then for the configuration, we are going to be using the Redis config class, the index name. So this is going to be the collection name called cached contains, and Redis URL. Since we are running Redis locally, the Redis URL is followed by Redis /localhost, and the port is 6379. We can confirm this if we run docker ps, and as you can see, this is the Redis stack, and port 6379 is being forwarded to my local machine. So this is running, and we can use this. And for distance metric, we are using cosine. So we can use Euclidean and other distance metric, but cosine works pretty well for this. So we are using cosine. And the next is metadata scheme. So metadata scheme basically defines what type of metadata structure we will have for our entries in the vector database. And for this, the name of the entry is going to be, or the name of the metadata is going to be answer, and its type is going to be text. So when we store data inside of this Redis vector store, we are going to be storing question as the key and then answer as the metadata, so that whenever there is a semantic match between the query inside of the vector database, we are going to immediately take the answer from the metadata and return it to the user. And that is it for our getRedisStore function. It basically configures the Redis store and then returns an instance which we can use to insert data or query it. Now that we have our Redis store, next we are going to create a function that is going to store the data inside of the Redis store. So now we have this new function called create cached contains, and for this we have uploaded file as the first argument or the only argument, and it's of the type uploaded file from Streamlit. So whenever we are creating cache in our system, we are going to be using the CSV file format. It's basically going to have a pair of question and an answer. So if I have to show you an example, so cache content based on our current example where we are taking the AWS Certified Practitioner Exam Guide, let's say your application has a lot of queries coming in, and most of the queries are what is the target candidate description, and you immediately have an answer for that. And another question might be, what is AWS Certified AI Practitioner? Again, you have immediately answer for that. So it depends on what kind of system you are building. You may put different columns here as well depending on your use case, but this is the most straightforward example that I can show you right now. And this is the CSV that we will be storing on our Redis vector database as well. Whenever we upload the CSV file in our application, what we are going to do is we are going to pass that CSV file inside of the create cached contains function, and then we are going to get value. This basically returns the bytes of the file, and then we are going to decode it to UTF-8, which is going to convert it into a string. And we are going to see this in an example later on where I put a breakpoint and show you what the values exactly look like. And now we are going to create a CSV reader instance. So CSV reader instance is an instance of a dictionary reader. And then we are wrapping the data that we read, which is a string data inside of a string IO. We are wrapping the data inside of a string IO because we need a file-like object whenever we are passing a data to dictionary reader. And if we come down, we have a empty list, which is called docs, where we are going to store all of our document, which is a LangChain abstraction. Now we have our CSV reader with all of the data that we have passed from our CSV. So basically this one, when we show the example later on, or can be this one, which is also a collection of question, answer. We are just going to ignore the instruction for the time being. So we are going to be taking each row from the CSV file. So for each row in CSV reader, and then we are going to append to our list. We are going to append a document, which is a LangChain abstraction. Page content is going to be row question. So if we see, row question is going to be what is the target candidate description. So this is where we are going to be using, or this is where we are going to be calculating the semantic meaning. That is going to be our cache key, let's say. And after that, there is metadata whose key is going to be answer, and we are going to put answer from our CSV file as a metadata. And once we have that, we are going to loop through all of the rows in our CSV and then store it inside of the docs. And then we are going to get the Redis store that we just created. And then basically we are going to add the documents, all of the documents that we have created inside of the vector store. And finally, we are going to show a message, success, cache contents added. Now that we have the backend for our application ready, where we can upload a CSV file and put it into a Redis in-memory vector store, we are ready to move to the front end of the application. And for that, we are going to move to the very end of our application, where we have the if name equals to main block. And this is the sidebar of the application, where we have the document upload area. Here we are going to update this upload file variable, which is basically Streamlit file uploader. We are going to support PDF as well as CSV here. And then I'm also going to add a help message, which is going to say upload CSV for cached results only. Just as a reminder for the user, they do not upload PDF or any other file formats for the cache. Obviously, you can update this and support any other file formats that you would like. But for this demo, I'm just going to support the CSV file format. And with that in place, I'm also going to add a radio button, which I'm going to call upload option, and it's going to say upload options. And the options are going to be primary or cache. If it's primary, then we are feeding the data to our vector database, which is Chroma, and we are using PDF file. And if it's cache, we are using CSV, and this is only for the data that is high on demand, which we can serve immediately. And also there is a help message where we are saying choose primary for uploading document for Q&A. And then we have 2-line breaks so that it looks visually appealing. Choose cache for uploading cached results. With that in place, I'm going to run my server again. Let's see how this looks on the front end. I'm going to go to my browser and I'm going to refresh this. And as you can see, we have this new upload options, which is primary and cache. It is primary by default. Now the drop location also shows we support PDF and CSV, but we have this help tooltip as well, which says upload CSV for cached results only. And if we come to the upload options area, there is also choose primary for uploading documents for Q&A. And right after the radio button, we are also going to check if we have selected the correct option for primary and the type of file we are uploading. So basically what we are saying is that if there is an uploaded file and the option is primary and the extension of the file is CSV, then we are going to show a error message, which is going to say CSV is only allowed for cache option. And our program is going to exit with the error code or the exit code 1. And coming down, we have this logic on our application where if there is an uploaded file and if the user presses the process button, which is basically this, then we are going to parse the document and upload it to the vector store. There's going to be a slight change. So if let's say upload option equals to cache now, what we are going to do is that all splits is going to be create cached contents, and we are going to pass the uploaded file as a parameter, and else we are going to process a PDF and put it inside of the Chroma DB. So if we take a look inside of it, we are taking the CSV file and then we are converting it into document and storing it to the vector database. If I go inside of this and if I put a breakpoint here, now let's see what this looks like step by step. So for this demo, I'm going to be using cached contents for my demo. You can find this on the repository linked in the description below. So my application is running. I'm going to go to my application. And then first of all, I'm going to select cache because I'm loading the cache initially. I'm going to go to my finder. I have this cached contents.csv here. I'm going to put it and it works. Just to show you that there is an error message if we select primary. So if I select primary, it says CSV is only allowed for cache option. So I'm going to select cache option and I'm going to select process. And I'm going to come back to my code editor, open my terminal. My breakpoint is right here. So if I do uploaded file, it's going to be a instance of uploaded file from Streamlit. And now let's see what we are doing when we are doing uploaded file.get value. So let's start with this uploaded file.get value. We are going to get bytes. And now if we do uploaded file.get values.decode and convert it to UTF-8, then as you can see, we have this B and then quotation mark. It's going to convert it into plain string. Now there is a typo. Instead of decode, I've written decide. So I cannot decide the spelling. So yeah, basically it's converted into a native string now. As you can see in the previous example, where we are just getting uploaded file.get value, it's getting bytes. And now we are converting that bytes into UTF-8 string, which is this. Let's move on to the next step. So we have this data. This is formatted with N. You go to the next step. So we were here. I pressed N. It executed this line. And now we are on this line, which is yet to be executed. If I do string io.data, then it converts it into a string object. And let's go inside. Our docs is empty. And we are going to go inside of the for loop. And we are at this line, docs.append. So we are going to take a look at the row. So it's going to be in a dictionary format. So if I take a look at the row, we have the key question and then we have the key answer, but which is definitely very hard to see. Okay, here is the answer, but you can also do row.keys to see that there are question and answer in this row. And we are basically taking that and putting it inside of the docs. So if we do this docs.append, and if we check the docs, there is already a document, which is the first line of our CSV file, which is what is the target candidate description. I'll just press C, continue to carry on whatever it wants to do. So it will not consider stopping anywhere else unless there is a breakpoint. So I'll just do C. My application is running, and as you can see, cache contents has been added. So our cache is loaded into in-memory database Redis. Now let's see how our cache looks like. For that, I'm going to open a new terminal instance. And if I do docker ps, the name of my container is stoic dhawan. So what I'm going to do is docker exec minus it, which means I'm going to attach a interactive TTY or terminal inside of the container named stoic dhawan, and I'm going to attach a bash terminal. With that in place, I'm going to write redis minus CLI to go inside the Redis database, and then I'm going to write all caps keys asterisk. And as you can see, we have two cached contents, one for each row on our CSV file. But if we use any visual tool like Redis, which I'm using in this case, so if I refresh this, I can see two cached contents. And if I look at it properly, I can see that the text is what is AWS Certified AI Practitioner. And the answer is basically here. So now our cache is loaded and it's ready to fire up. But before that, we do not have anything to query the cache. We just have a function which creates a cache content, and we just created a function which returns the Redis cache store. So next we are going to create a function which is going to query the Redis cache and return us the results if there is a match up to a certain threshold in the semantic meaning. Here we are going to write our function, which is going to be called query semantic cache, and it's going to take a argument of query, which is whatever the user types on our UI. Number of results for this, I'm just going to put it as one, because whenever we are querying the vector database, it usually returns the most relevant result as the top result. So we will not need more than one, because we are going to take the first result, the top result, and we are going to check how much similar it is with this threshold. And for this, we have this threshold argument of type float. And for this demo, we are going to use 80 percentage as the threshold, meaning whatever query we are running and whatever key that is stored on the vector database, the semantic meaning should be 80% similar. On the next line, we are getting the vector store, and then we are querying the vector store with similarity search with score. So this is going to return a cosine similarity score, because if you go to the get Redis store, we have the distance metric as cosine. So whenever we are running this function, it is going to return cosine similarity. And then we are going to pass the query, and the number of returned results is going to be 1. And sometimes if it does not return any results because there is no similar data, then it's basically going to return none. And then here is the interesting part where the threshold comes into the picture. So what we are doing is that it returns a cosine similarity, and we are converting that cosine similarity into a cosine distance. And for that, we are going to take 1 and subtract it with the absolute value of the cosine similarity that the results return. And as you can see, we are taking the first value, because it returns only one value, but it's a nested list. So we need to take the first item from that list. And then we are going to take the second item, which is going to be the cosine similarity from it. And then we are going to multiply it by 100 so that we get a percentage. And then percentage is basically a pretty weird name. I think I should name it as match percentage, maybe. Yeah, this sounds more like it. So if the match percentage is greater than or equal to 80%, then we are happy with our results. And if there is a match, we are going to return the results. And if it does not match the threshold, we are basically going to return none. And if we come down to the main application block here, we'll toggle the sidebar. And now we are just left with this section. So before we go to query collection, which is going to hit our vector database, and then it's going to perform cross-encoder re-ranking and all of this jazz, we are going to put cached results here. So cached results is going to be query semantic cache, and then the query is going to be our prompt. Once we do that, we also need to check if there is cached results or not. So if there is cached results, we are just going to do st.write, and then cached results, we are going to take the first item in the cache results, because we are just returning one item from the vector database. And then we are going to the zeroth item, which is going to be the document object. And then we are going to say metadata is where our answer is. So we are going to take answer here. And if there is no cache results, then we are going to perform all of these jazz. So we are just going to put this inside of a else block. Now let's see this in action. Let's see like how this semantic query works. So first of all, we are going to ask the question that is going to be like 99% match, because I'm going to ask the same question that we feed it to the vector database. But I'm also going to put breakpoint here. Let's see if I have other breakpoints. Yeah, I'm going to remove this breakpoint. It's no longer needed. I have just one breakpoint, which is when I'm querying the semantic cache. So let's go to our application, and then I'm going to paste what is the target candidate description. Then I'm going to ask the question. And then if we go back to our terminal, we will be stopped here in the results. So if I look at results and len of results, it's going to be 1. So we are just returning 1 because our and results is 1. And as you can see, it is returning this data as a list. So we need to get the 0th index item, which will return this tuple again. And then we need to take the 0th index item of this tuple, which is finally the document object. but as we can already see, there is a metadata field. The second item here is the score that we are looking for, which is the cosine similarity score. So if I do absolute 0, I'm going to get a document where I can do document. If I go down, if I can do like dot metadata, it gives me a metadata, which is a dictionary, and get answer from here. But if I want to get a result, which is the cosine similarity, then I have to use the second item, which is going to be this value. So let's go to the very top, and now we are using the match percentage. So if I do next and match percentage, and if I check match percentage, you can see it's 99.99994, which basically means it's pretty similar. And if I do C, it's going to immediately return the answer to my system. And as you can see, we are seeing these weird characters, line break characters, backward slash minus n. This is because, let's see, if we are asking the question and if we see the results, you can notice there are double backslash followed by an, the line break character. So if you have double an, it basically skips the line break character, which results in this line break character not being rendered to our screen. So to fix that, what we are going to do is come very down, and wherever we are fetching the answer, we are going to do replace followed by this. I need to delete this, put it here, and then it works. So I'm removing, or I'm replacing double slash n with a single line break character so that it renders the line break properly. I'm going to run it again. So if I come down here, nothing's going to change. I'm just going to remove the debugger now. So if I come to my application again, and if I ask the question, as you can see, it's well formatted and it gives me the answer within milliseconds. I can try another. What type of person can give the exam? And I can ask it. So you can also set the threshold to, maybe 70 if it makes sense for you. I'm going to see the results again. And then it's just giving the exam overview for the most part. And then I'm going to do next. I'm going to check the match percentage. It's just 54 for this time. So it's going to go through the large language model, cross encoders, re-ranking, and all of that. So there are also different ways of questioning the model. What is AWS certified AI practitioner? So instead of that, I can just ask, tell me about AWS certified AI practitioner. So it's going to get the results. And then as you can see, it has a cache hit, but we need to check the threshold. So if I go here and if I check the match percentage, it's 96, not 99, but it's going to return the result immediately. So if I do C, as you can see, all of these are cast results that is being returned immediately. So you can play around with this for a bit and figure out what works best for you and what is the best strategy moving forward. Also in the code base, you can find some handy scripts, which is inside of the scripts. If you are feeding in a large amount of data inside of the vector database, then you need to take the amount of token into consideration. So this function or this module basically helps you to identify if you are passing the correct number of tokens inside of the embedding function. And if not, then you can like trim your answer or make it however you want. And if you want to see how I made the CSV file, first of all, what I did is that I take all of the questions. For this example, I'm just taking 2 questions, which is very high in demand. Let's say a lot of people are trying to know about the AI exam from AWS, and they are constantly asking question about that to our system. Then we decide to cache it. So basically, this is the question and this is the answer. Also notice that this is a raw string so that it does not render this line break characters. And yeah, the name of the file is cached contains. And you also have this mini movie CSV, which I got from Hugging Face. There were like 30,000, 40,000 data inside of this CSV, but I cleaned it up. And I think there are only 500 data for the time being. Yeah, so you can use this as well. That's it for this video. Thank you for watching. If you like this video, give us a thumbs up. And if you want to see similar content in the future, please subscribe to my channel. And I'll see you in the next one.